This is section 2.1, part 1, where we're going to look at representing relations and also identifying whether that relation is a function or if it's not a function. So before we get into the problem, there's three pieces of information we need to know what they mean. Ordered pair, domain, and range. So an ordered pair is two numbers, a number that represents your value of x and a number that represents your value of y in parentheses. So it's some number, comma, some number. First number is x, second number is y. Your domain basically represents all of your x values, whereas your range represents all of your y values. So we're going to need to know those for the next problem, which we see down here. So the problem is right here. All right, so you're given -1, comma 0. That's your first ordered pair. Second ordered pair is 0, comma -3. Third ordered pair is -1, comma 3. And your fourth ordered pair is 2, comma 1. So we have a set of ordered pairs. And the first thing we're asked to do is basically identify the domain and the range. So if you remember back up here, we saw that we know what the ordered pair is, and the first number is all of our x. Those are all of our x's, and the domain is basically all the x values. So in order to list your domain, you essentially just want to go ahead and look at all of your x values and write those down. I just want to make sure I'm in green. So my first x value is -1. Second x value is 0. -1. And then lastly, 2. My range is all of my y values, so that's the second number in the ordered pairs. So all I need to do is list those. So I've got 0, -3, +3, and 1. And I've listed my domain and my range. Once you've done that, the next part of the problem tells us to represent the relation using a graph. Alright, so I've got the graph provided here. So basically the relation is the set of ordered pairs that you're given. Alright, so your relation is your set of ordered pairs. So I will write that here. So we just want to plot each ordered pair in this graph. So the first ordered pair, I need to scroll back up to the problem, is -1, comma 0. We know -1 is our x value, so I'm going to start at 0, comma 0, go to -1, and it's also -1, comma 0, so I don't need to move up or down on the y value. So that's my -1, comma 0. Second ordered pair is 0, comma -3. We see that right here. So my x value is 0, so I don't need to go right or left, but I do have to move down 3 units on the y-axis because the y value is -3. So I'm going to go down 1, 2, 3. Plot my second point here, and I've got 0, comma -3. Third point is -1, comma 3. So I'm going to move over to -1, and I'm going to move up 3 units. So I've got -1, comma 3 right here. And my last point is 2, comma 1. So my x value is 2, y value is 1. So I'm going to move right 2 units, up 1 unit. And we see it's 2, comma 1. So I've represented the relation using a graph. I've just had to plot my points on the xy coordinate plane. Last thing you're asked to do is to use the vertical line test to tell if the relation is a function or not. So before we can do that, let's learn what the vertical line test is. Alright, so I've got two different relations graphed here. So I want you to take a moment and graph these relations. Alright, so we got our vertical line test. So we see here In the first relation, we have a point at -1, comma, -1. We have a point at 1, comma, 0. Another point at 1, comma, 2. And the last point at 3, comma, 0. Over here in this relation, we have a point at -1, -2, -3, comma, 1. Second point at 0, comma, 1. Third point at 2, comma, -2. And fourth point at 3, comma, 3. So what a vertical line test tells us is we want to look at each of the points drawn and draw a vertical line straight up and down right through that. Alright, so if I were to do that, alright, I would have a vertical line here. I would have a vertical line here going through those 2 points, and then a vertical line here. And the question is, does this represent a function? Alright, we're looking just at the first one right now. So going down, I will tell you that this does not represent a function. This is not a function, and the reason is this vertical line right here that I will make a little darker. Alright, that vertical line, whoop, sorry about that. That vertical line passes through more than one point. It passes through 1, comma, 2 and 1, comma, 0, so it's not a function. This relation over here is a function, because if I were to draw a vertical line through each of these points, we would see that the line passes through only one point each time. So if your vertical line passes through just one point, or only one point, you know you have a function. So function is that vertical line only passes through one point. So what part of our ordered pair will help us identify whether we have a function or not a function? Well, what's going to put 2 points above each other is the value of x. What do you notice about the value of x here? We have 2 values of x that are exactly the same. So if you have 2 values of x that are exactly the same, that's another indication that you don't have a function. Whereas here, look at our values of x. We've got -3, 0, +3, and +2. Alright, each of those values of x's are different, thus the vertical line only passes through one point each time. Alright, so we have a function. So knowing that, let's go back to our problem up here and use our vertical line tests. Alright, so we'll draw a line through each point. Alright, so if we were to draw a line through this point, we can see that vertical line only passes through one point. Here, vertical line only passes through one point. Here, we see vertical line passes through 2 points. And again, what do you notice about the x values? -1, -1, they're the same. So, we know we do not have a function. It's not a function because our vertical line has passed through more than one